On February 20th, 1943, north of the Kasserine Pass in Tunisia, battle reports would never fully capture what German tank commanders saw that morning. American Sherman tanks carried out maneuvers that went against everything Wehrmacht doctrine claimed was possible without visual signaling. Through the haze of dust and smoke over the North African battlefield, 5 Shermans separated by broken terrain and with no line of sight. Between them, closed in on German positions with coordination that seemed almost supernatural. There were no flags, no flares, no messengers rushing between vehicles. Yet they moved as if they were one body, each tank covering the blind spots of the others, every crew perfectly aware of where their comrades were. Inside Panzer IVs equipped with Fuji-5 radios, German commanders struggled to even hear their own leaders through the static that overwhelmed their amplitude modulation systems. Their 10-watt transmitters, cutting edge in the 1930s, could barely push signals more than a few hundred meters when tanks were in motion. Most Panzers had only receivers, unable to report sightings or call for assistance. The Americans, meanwhile, operated with technology the Germans hadn't realized existed: frequency modulation radios, installed in every single tank, running on crystal-controlled precision, with 25 watts of power and clarity, sharp enough to cut through engine, roar and battlefield chaos like a knife through paper. 8,000 miles from Detroit's assembly lines, the war's most decisive technological edge was revealing itself not in armor or firepower, but in the invisible radio waves linking American tank crews in ways the Wehrmacht had never imagined. The change began on July 22, 1941, when the U.S. Army standardized the Signal Corps radio sets SCR-508, CR-528, and SCR-538 for all medium tanks, while German forces pushed deep into the Soviet Union, relying on command vehicle radios. American engineers at Galvin Manufacturing Company, later known as Motorola, were perfecting FM technology that would make German systems obsolete. The team included Daniel E. Noble, who envisioned FM's military application, and Henrik Magnuski, the lead RF engineer who solved the problem of fitting complex electronics into the hostile environment of a tank. Their creation, weighing 181 pounds, turned every Sherman into a node in the world's first battlefield-wide communications network. The BC-604 transmitter put out 25 watts, 2.5 times more powerful than the German Fuji-5, operating on the 20.027.9 MHz band. It provided 10 crystal-stabilized preset channels. Dual BC-603 receivers in the SCR-508 even let commanders monitor 2 frequencies at once, a decisive advantage. But the true revolution was frequency modulation itself. Edwin Armstrong's FM breakthrough, licensed to the U.S. military, wiped out the static that crippled AM systems. While German radios picked up every electrical spark as noise, American FM delivered crystal-clear voices even under heavy artillery fire. On November 8, 1942, Operation Torch landed American armor in North Africa. The 2nd Armored Division brought Shermans ashore at Safi and Fadala equipped with SCR-508 sets, soon proving their superiority over German communications. Even the vaunted Africa Corps, the Wehrmacht's most experienced armored force, was crippled by severe communication limits. In a standard German platoon of 5 tanks, only 1 or 2 carried full Fuji-5 transceivers that could send and receive. The rest had Fuji-2 receivers only. Orders could be heard, but no reports or warnings could be sent back. Coordination relied on strict hierarchy. The platoon leader issued commands, and subordinate tanks obeyed silently. If the command vehicle was knocked out, easy to identify by its antennas, the entire platoon lost direction. Against American forces, where every tank could instantly assume command, this weakness became catastrophic. At the Battle of Kasserine Pass, February 14, 1943, American radio superiority made its first major impact. Though the fight ended as a German tactical win, it revealed capabilities that stunned Wehrmacht observers. Amid chaotic engagements, scattered elements of the U.S. 1st Armored Division stayed connected across 50 miles of battlefield. Crews who had never met coordinated maneuvers warned each other of threats and called for artillery through flawless FM networks. German signals intelligence units intercepted these transmissions and noted their clarity and coordination. Reports from the 10th Panzer, Division's intelligence section admitted that Americans maintained communication at ranges where German sets delivered nothing but static. Worse still, it appeared that every American tank had full transmit capability, not just command units. The few G5 radios, operating on AM in the 27.0-33.3 MHz band, faced fundamental flaws. Their 10-watt transmitters barely reached 2 to 3 km under ideal conditions, dropping to a few hundred meters when tanks were in motion. Every spark plug firing, every electric motor, every grinding track produced interference that AM could not filter out. By September 1943, American armor was advancing into Italy. In the mountains, terrain that should have nullified radio advantages. Instead, FM technology proved even more valuable in situations where German AM radios became completely ineffective. The SCR 508's frequency modulation handled the multipath interference of mountain valleys far better than amplitude modulation. American tanks were able to coordinate movements in terrain where visual signals were impossible, while German radios failed outright during the advance toward Cassino. U.S. armored units displayed capabilities that Germans couldn't comprehend. Platoons of tanks separated by ridgelines, synchronized attacks, with precision that German doctrine insisted required direct visual contact. After-action reports from the 1st Armored Division recorded routine coordination at ranges, where German radios transmitted only static. On June 6, 1944, as Sherman tanks rolled off landing craft at Normandy, their SCR 508 radios maintained live contact with naval fire support, coordination that German technology could not achieve. Yet the hedgerow fighting exposed a critical shortfall. Tank radios could not connect with infantry sets that operated on different frequencies. The infantry's CR300 ran on 40.0, 48.0 MHz, while the tank's 20.0, 27.9 MHz range made them incompatible. This communication gap proved deadly in the bocage, where German infantry with Panzerfausts could ambush Shermans while American troops nearby had no way to warn them. U.S. innovation solved the problem within weeks. Tank crews mounted EE-8, field telephones and ammunition. Boxes welded to the hull exterior, wired directly into the tank's intercom system. By Operation Cobra in late July, this simple modification had transformed tank infantry cooperation. From July 25th to 30th, 1944, Operation Cobra showcased the full power of American radio superiority. Major General Edward H. Brooks, 2nd Armored Division coordinated more than 200 Shermans through FM networks that allowed unprecedented battlefield control. German defenders of the Panzerlehr Division faced an enemy that seemed to possess near-omniscient awareness. American tanks reacted instantly to threats reported by units miles away. Artillery fire, coordinated through tank radios, struck within minutes of target identification. The contrast with German capabilities could not have been sharper. Panzerlehr, once the elite of Germany's armored divisions, had fallen into communication poverty. Most of its tanks operated without radios, forced to rely on visual signals in terrain where visibility was often less than 100 meters. The few radios still in service suffered from interference and limited range that crippled coordination. The irony was unmistakable. Germany had pioneered the use of radios in armored warfare. Heinz Guderian, architect of Blitzkrieg, had insisted on radio equipment in tanks since the 1920s. His Neues in Reichsburg Achtung Panzer emphasized communication as essential to armored operations. Guderian had personally overseen development of radio systems that enabled tank officers to coordinate lightning-fast advances. He knew reliable communications were the heart of mobile warfare. Yet by 1943, German industry could no longer produce enough radios to meet his doctrine. Production figures revealed the crisis. In 1943, Germany built roughly 5,700 medium tanks but fewer than 2,000 FUG transceivers. Many of those went to command vehicles and assault guns, leaving ordinary tank units without adequate communications. The Soviet Union suffered even worse shortages. The T-34, despite being the most produced Allied tank, usually went into battle without a radio at all. Soviet doctrine depended on flag, signals and prearranged plans with disastrous results against German forces in 1941. By 1943, Lend-Lease deliveries provided some relief, as U.S. sets including SCR-508s were installed in Soviet command tanks. But even by the war's end, only about 25% of Soviet armor had radios. This contrast highlighted America's achievement. While the Soviets struggled to equip even 1/4 of their fleet, the U.S. managed to put sophisticated FM radios in every tank. Motorola's Chicago factory became a symbol of American industrial mobilization at its peak. Before the war, the company built car radios. Converting to military production meant total retooling and solving unprecedented engineering challenges. Each SCR-508 required 2,148 individual parts, built to exacting standards. The BC-604 transmitter alone contained 474 capacitors and 385 resistors, crystal oscillators, had to hold their frequencies stable under extreme temperatures and violent vibrations. Production numbers told the story of America's industrial strength. 1942, 3,800 SCR-508 family radios. 1943, 11,400 units. 1944, 24,000 units. By war's end, more than 50,000 tank radios had been produced, enough to equip all 49,324 Shermans built during the conflict, an accomplishment no other nation matched. The SCR-508's superiority extended beyond FM clarity. Crystal-controlled frequency stability meant channels could be preset before battle and would remain aligned under combat stress. German Few G5 radios, by contrast, relied on variable capacitors that constantly drifted off frequency. Dual receivers let commanders monitor both platoon and company nets at once, ensuring orders flowed instantly up and down the chain. The BC-606 intercom integrated seamlessly with the radio, allowing every crew member to alert the commander to threats. Throat mics and noise canceling headphones enabled intelligible communication, even in combat chaos. Many German tanks lacked intercoms altogether, forcing crews to shout or rely on touch. Power supply provided another advantage. The SCR-508 could run on either 12 or 24 volts, automatically adapting to available current. Its dynamotor supply filtered out interference, ensuring clean signals. German radios, powered directly off tank electrical systems, picked up every spark as disruptive static. Universal deployment of advanced radios fundamentally reshaped American armored doctrine. The combat command structure, flexible, task forces built for specific missions, relied completely on dependable communication. U.S. commanders could assemble improvised battle groups from multiple units, confident that compatible radios would keep them coordinated. This adaptability confused German commanders, who were tied to rigid formations forced by poor communications. At the Battle of Aricourt in September 1944, the U.S. 4th Armored Division confronted several German Panzer brigades armed with superior Panther tanks. On paper, the Germans held the advantage in armor and firepower. Yet American radio coordination tipped the balance. Every Sherman crew could instantly report enemy sightings. Tank destroyers received firing data from tanks out of their visual range. Artillery observers riding in Sherman command. Tanks called down barrages within minutes. Over 3 weeks of fighting, the 4th Armored destroyed 281 German armored vehicles while losing only 41 Shermans, an astonishing 7.1 kill ratio that defied expectations. Throughout the war, German intelligence never understood the real edge of American forces. Reports noted U.S. coordination, but chalked it up to discipline and training rather than superior radios. A September 1944 intelligence assessment observed, American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures. The report entirely overlooked the technological foundation. German tactics never adjusted. They kept aiming for supposed command tanks by spotting antenna layouts, unaware that every Sherman had full radio capability. They set ambushes expecting American coordination to collapse when units split up, never realizing radio contact preserved cohesion even without visual contact. By March 1945, as U.S. forces neared the Rhine, American communication superiority reached its peak. The capture of the Remagen Bridge showed the unmatched speed of U.S. command and control. When the 9th Armored Division found the Ludendorff Bridge intact, radio messages reached 1st Army HQ within minutes. Within an hour, entire divisions were repositioning to seize the opportunity. German forces, still reliant on telephone lines that U.S. aircraft systematically destroyed, could not react with comparable speed. Radio coordination allowed U.S. forces to establish an unbreakable bridgehead defense. Tank platoons from different battalions worked together seamlessly, linking fires through radio nets. German counterattacks, poorly organized due to communication breakdowns, arrived piecemeal and were crushed one by one. In April 1945, during the encirclement of the Ruhr Pocket, U.S. communication superiority delivered its final masterpiece. Armored columns from the 1st and 9th Armies carried out a massive double envelopment coordinated entirely through radios. Inside the pocket, 325,000 German troops were trapped largely because their communications collapsed. U.S. fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German command posts and relay centers. Wehrmacht units lost contact with headquarters and even with each other. Field Marshal Walter Model's final transmissions captured the desperation. No contact with adjacent units. No communication with higher headquarters. Fighting continues but coordination impossible. This contrast reshaped the psychological experience of tank warfare. American crews fought with confidence, knowing they were never cut off. Radio networks ensured constant connection. German crews endured the opposite, isolation. Lacking radios, they fought as lone machines within larger battles. Otto Carius, one of Germany's top tank commanders, reflected in his memoir, Tigers in the Mud, on the immense difficulties caused by poor communications, though he emphasized tactics more than the systemic gap. The strategic consequences were immense. From 1944-45, U.S. advances maintained their tempo largely because of radio coordination that Germans could not match. Patton's Third Army's dash across France depended on radio networks that kept control over forces. Stretched across hundreds of miles, German commanders persistently underestimated American capabilities, unable to imagine the scale of U.S. communication superiority. Heinz Guderian, as Inspector General of Armored Troops, recognized the issue but could not resolve it. In a December 1944 memo, he admitted that American coordination nullified German advantages in tank design and firepower. After the surrender, U.S. technical teams studied German equipment and confirmed what the battlefield had already proven. German tanks often surpassed American ones in armor and guns, but their communications were disastrously inferior. U.S. Army Technical Intelligence Report. Number 176 concluded that German radio technology lagged about 5 years behind. The lack of FM, the limited distribution of sets, and poor suppression of electrical interference created fatal weaknesses. Soviet analysts reached the same conclusion. Granted access to captured German equipment, the Red Army chose to copy American radio systems for its post-war designs rather than German ones. Production numbers revealed the scale of American achievement. U.S. industry produced staggering totals of SCR 508, SCR 528, and SCR 538 radios, over 50,000 units. A total of 49 of 324 Sherman tanks were produced, each one equipped with radios, a 100% deployment rate. Their transmitters delivered 25 watts of power, with crystal-controlled frequency stability of plus 0.1%. Communication range reached 7 miles while moving and 10-15 miles when stationary. By comparison, German production of Fuji-5 transceivers amounted to only about 6,000 units, against nearly 12,000 medium and heavy tanks built. This gave them a full transceiver deployment rate of only around 20%. German radios transmitted at 10 watts, with variable frequency stability of plus 1%. Their effective range was 0.5 to 1 mile on the move and 2-3 miles when stationary. The contrast in combat efficiency was stark. American units averaged just 3 to 5 minutes to call and execute a fire mission, while German units required 15 to 30 minutes. U.S. tank formations achieved virtually 100% coordination, while only 20% of German tanks had the ability to communicate effectively. Sherman radio superiority laid down the foundations of modern armored doctrine. Today's main battle tanks carry advanced digital communication suites, directly descended from the SCR 508, still built on the principles of universal issue and dependable coordination. In the 1950s, the rebuilt Bundeswehr made communications a top priority, applying lessons of WE. Every Leopard tank carried full radio systems. A Bundeswehr training manual captured the point clearly. The defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority. Modern wars confirmed the lesson. In the 1991 Gulf War, coalition forces armed with better radios annihilated Iraqi units equipped with technically stronger, Soviet-designed tanks but weaker communication. In 2003, the U.S. again proved that network-centric warfare beats platform-centric warfare. The radio advantage of the Sherman was more decisive than armor or firepower. German crews fought much of the war half-blind to this revolution, learning too late that each Sherman was not just a tank but part of the world's first armored battlefield network. The SCR-508 transformed the M4 Sherman from a solid medium tank into one node of a collective weapon system linking every U.S. tank together. That invisible connection proved more decisive than any thicker armor, plate, or larger gun. Every Sherman carried victory not just in its 75mm cannon or sloped armor, but in the 181 pounds of radio equipment that tied its crew into a shared intelligence system no German tank could match. German units discovered this painfully at Kasserine Pass, in Italy's mountains, in France's hedgerows, and on Germany's soil where American tanks achieved coordination their doctrine insisted was impossible without visual contact. The Wehrmacht never developed an answer because it never fully grasped the scale of the technological gap. Field Marshal Wilhelm Keitel is often quoted at surrender saying, "We knew how to build better tanks, but you knew how to make them work together." Whether exact or not, the statement reflects a deeper truth. America had not just built 49 324 tanks, it had created 49th and 324 interconnected battlefield nodes. Historians identify network-centric warfare with the late 20th century, but its roots trace back to 1942, the year the first Sherman with an SCR-508 entered combat. From that moment on, victory belonged to the side with superior communications. The network would always beat the platform. The connected would always defeat the isolated. For Germany, the recognition came too late. They witnessed U.S. coordination in battle after battle, but never realized its technological foundation until the war's end. By then, their failure to adapt had sealed their fate. They built excellent tanks that fought alone, while America built adequate tanks that fought together. In the end, the invisible electromagnetic waves of the SCR-508 proved deadlier than even the 88-meter shells of German guns. The ability to coordinate, share information instantly, and fight as a united force mattered more than armor thickness or firepower. The Sherman's radio network changed warfare permanently, establishing the core principle of modern combat. Connection means survival. Isolation means defeat. Across 3 continents, German troops learned this lesson the hard way, realizing too late that America's true superiority lay not in numbers alone, but in mastery of communication.